Awesome. Thank you, TJ. All right, so yeah, today's talk is going to be about making proof of concepts that are unignorable. A little bit about me. I do application security practice lead for VDA Labs, a small cybersecurity firm based out of Grand Rapids, Michigan. One of the founders of the local Charleston InfoSec group. And I've, ever since BSides 2016 maybe, started hacking ATMs. And I've done that a couple of times since then, including spending a couple of weeks with an ATM manufacturer, learning all we could about a specific ATM and then breaking it so that they could make sure it was good before they put it out to the public. So what is this talk about? This isn't about shiny new novelty exploits or 0 days. Instead, this is about building proof of concept chains that make security unignorable. And if you've ever had to fight to get a bug taken seriously, this talk is for you. Before I begin, I will start with this. As a developer long, long ago, we had a mantra on our team. It actually came out of a book, Writing Secure Code, that was written in like 2002. But all user input is evil. If all developers took that to heart, I'd have a lot harder job to do as an attacker. On the flip side of that, as an attacker, all user input is a potential code execution vector. So I love input into an application because it gives me a chance to have your program do something with data that I control. So keep those things in mind as we go through this. And this talk is going to be kind of a story-driven talk. We're going to look at really grabbing someone's attention with a stored cross-site scripting. And some of you might be out there thinking, wow, cross-site scripting is still a thing? Yes. Unfortunately, there's a lot of it out there. And unfortunately also, many places don't seem to take it seriously because what's the traditional evidence for the cross-site scripting when you put it in a report? You've got an alert box with a cookie in it or maybe a message, right? And they look at that, and the unimaginative people that look at that say, oh, well, it's just a message. I don't care that somebody can put a message on there. I'm not going to fix that. So we'll make it so that they can't ignore it. We'll also tell about the day I found out that I am a highly sophisticated threat actor. It's a plot twist on a classic DLL injection. And then finally, we're going to look at how I abused verbose error messages and misconfiguration in an application to implement my own feature in a client's web application that gave me full account takeover capability for every account in their system, all 68,000 of them. So with that, let's jump into the first story. So this starts out with a cross-site scripting vulnerability that was found in an application. And in fact, this particular one was a repeat. Like we had tested the client the year before, found the stored cross-site scripting, gave them the traditional evidence tag. They basically said, okay, that's nice. And then the following year when we tested it, they hadn't fixed it. In fact, my old payload was still in that test environment. I was like, wow, you guys really just didn't do anything with this. You know, they fixed some other stuff, but this particular vulnerability, they were like, meh, whatever. So I decided, well, I'll just make it so they can't ignore it this time. Started out pretty boring. I was getting the first proof of concept. You know, again, I want to make sure that the cross-site scripting payload can actually fire. So, of course, you do it with a quick message. Now, one thing about this is they did have some protections, and this may be why they ignored it in the first place. You couldn't put in just a classic script, you know, alert, whatever, and then close script tag. Those payloads were scrubbed, so they were doing a good job with that. They also did a good job with scrubbing JavaScript event handlers. So a lot of times if you can't get a cross-site scripting payload to fire with your regular script tags, you'll end up using something like image equals this, and then on error, there's your payload, right? Well, they also blocked that. I said, okay, that's good. We're doing something. But what they didn't do was they still had a feature in their application where you could put in an anchor tag. So you could put that to anything that you wanted it to. And at first I was like, all right, I could maybe put that to something malicious, and it gets ingested into their website. But then I started thinking, could I make the data in that be the payload itself? So if you're a bit of a HTML nerd, there's data URL property for the href tags. Instead of putting the full link to a remote website, you can include your whole payload right there. The thing is, you base64 encode it. So I took my payload, the proof of concept, base64 encoded it, put it in a data URI, and that's what fired over here. You can see I kind of blurred out the full payload. Trying not to teach script kiddies here, but just want to show that it does work. So I decided to make it interesting. I had just gotten off of a project previous to that where I was doing a lot of work in testing with WebSockets. And so I thought, well, maybe I can make WebSocket control through this cross-site scripting payload. So I put together a little attack server, just threw up an EC2 instance in our Amazon cloud, and put a little Node.js server on there to handle some basic interactions. And then made that payload so that when the user visits the site and clicks that link, it opens up a WebSocket back to my attacker-controlled server. And so I get some limited control over their browser. So here we've got kind of the implementation of that. You got a little command shell up at the top showing the server running. And then when somebody connects, I get a notice that they've connected, and then I can start interacting with it. So first thing I did was send a console message, hello from the attacker shell. And it shows up at the bottom here where we've got hello from my attacker shell. All right, great. I've got some basic control now. But I also knew that with this particular client, if they didn't care about the potential for other stuff and they just saw the message, this was just another message. But instead of being visible on the screen, it was now buried in the console. So let's send them to other websites. Now all of a sudden I can just put like window open, push a URL in there, and now the browser is going to go to that website that I've directed them to. In that case, I can have a actual malicious website doing a whole lot more, and game over for the victim in this case. And in this case, the client was like, wait, so you can affect all the users who visit the website now? Yes, we could before, but you didn't pay attention. But now all of a sudden they paid attention, and they said they fixed it, but I haven't gotten a chance to retest this yet, so we'll see how that goes on the next round of testing. So the next story is about the day I found out that I was a highly sophisticated threat actor. A little backstory on this: I was testing a Windows application, a desktop application, and this particular Windows application, the application was vulnerable to DLL injection. This particular client had a history of deprioritizing DLL injection. In fact, they were telling us, like, we really don't care about that. And I'm thinking to myself, that's an odd choice to make, but okay. And I started thinking, how can I make them care about it? And I was, they weren't even really concerned about the initial thing with where you get remote code execution out of that DLL injection. So when I first told them that I was experimenting with that, I said, yeah, I can actually get remote code execution. I can get a reverse shell back to the desktop. And they're like, yeah, but we don't think that's really going to impact us. Okay. I take that, put it back in my mind, and start letting it think on some different ways that I can make it useful. So I'm looking at some other DLLs that they have, and I noticed in one of them, I was doing some little basic reversing, and in this other DLL that they had, they were storing JWTs and some other interesting tokens and stuff that I like to call loot when I'm an attacker and I'm looking for information on a system. This DLL started handling that. And I noticed that in the code for that, these tokens, these passwords, the JWTs were all being declared as string objects. So who's got a development background in here? All right, so what's the problem with storing sensitive information in a string? Anybody?
Really easy to get.
Easy to get, why?
Well, because you don't have to do anything to read it.
Well, so there's that, but beyond that, strings are immutable. So once it's declared in memory, it's staying in memory in that state. They can't overwrite it, they can't change it. It's just going to be in memory until garbage collection comes along and flushes that out, which developer may or may not have control over, or may or may not care about it. There's a lot of modern development frameworks that do garbage collection automatically, and so developers don't typically worry about that. So I started thinking, okay, if these objects are in memory, and I've got remote code execution, well, now I can go rifle through memory. Awesome. So I wrote a couple of regexes to look through the memory during my DLL injection attack and look for things like JWTs, passwords. I was looking for different hashes, if something was like MD5 hashed or, I just wanted anything that looked interesting in memory and pull it all out and put it in a little file for me to go look at later. And ended up getting all of those JWTs and then finding out that they're valid. So for those of you that aren't familiar with like web app testing, if you have a JSON web token and you look at it, you can see, is it valid? It's got an expiration date plugged into it, what resource it's for, because it'll have that as part of the properties of it. And so I start seeing that I've got tokens for other cloud services that this application interacts with. And to make it easy for the user of the application to export data or import data or move data around, they said, yeah, you can connect your cloud account to this repository and we'll handle that for you in the background. So now all of a sudden I have the DLL injection that lets me rifle through memory and pull out interesting information, in this case tokens, and then I can go masquerade as that user to whatever cloud service that token was for. And there was multiple tokens. So now all of a sudden, they had a couple of findings. One, don't store sensitive information in string objects. Go back to your dev team and have them re-architect that. But then also maybe fix the DLL injection, because the one finding isn't as impactful without the remote code execution that the DLL injection. So if I would have just came to them and said, you're declaring these sensitive objects in memory as strings and they can be gotten by an attacker, they're going to like, well, who's getting access to the local machine? Just that user that's logged in. Well, now their DLL injection gives an attacker local access to that machine and they can pull the same information. And when I was first looking at this particular attack path, I was concerned that this client was going to push back and say, oh, that's unrealistic. That's not a realistic threat pattern that would happen. So I reached out to a number of friends. TJ was one of them. And I said, have you seen this kind of activity? Or what would you say if you saw this kind of activity in the wilds, like, from a threat actor? And there was one other threat researcher that came back and said, I think I was dealing with a highly sophisticated threat actor. And I was like, awesome. I'm a highly sophisticated bad guy. So we turn the remote code execution into rifling through memory and grabbing fun stuff. So yeah, in the end, all of the JSON web tokens end up coming to me. And one thing that was interesting that came out of this as well, this particular client now specifically asks us to verify that DLL injection is no longer an issue in new stuff that they put out going forward, because they were like, yeah, that kind of was scary, so thanks for opening our eyes to that. I think where they got burned in the past was before they'd come to us for application pen testing, they were out on, there was a bug bounty platform, I don't know which one they were on, but they got a lot of people that were writing in, you know, basically the same thing, DLL injection, but all they would do is their evidence was always just, you know, a quick message, or it would launch calculator, right? That's another classic. If you're pen testing and you get something like remote code execution, what's a harmless thing I can do to prove that? I can launch the calculator on the app. And so they were looking at it and they're like, who cares if you can launch the calculator? But that, because that's how they were, that's the only thing that they were thinking, is that they weren't opening their mind to the broader possibility. Well, if I can launch calculator, I can launch any other EXE on the system, and including maybe one that I drop there. So like I said, they have their eyes opened now, and they're actively looking to prevent that in the future. So that was a fun one. Just for a quick thing, for anybody that's brand new, you can aware how basic DLL injection works to make that a thing. I'll give a quick overview, highly simplified. But basically with modern Windows applications, you have, the application isn't going to be written to contain everything in that main executable. There's some things that it's going to do that is going to be called out in another piece of code. And so they'll have these libraries, the DLLs, the dynamically linked libraries, that may contain certain functions for the application to use. And so rather than it being written in the main application, it goes out to this DLL and calls the code from there. Well, in Windows systems, it has a specified search order that it looks for those DLLs. It starts in like the applications directory, and then it kind of has a prescribed pattern that it follows where it looks for a specific DLL when it needs to access that information or that function. And you can fire up a process monitor on your machine, launch an application, and kind of see where it's trying to read for that information. So I'll find the name for a DLL, just call it app.dll, and it's trying to load it, and it can't find it. So I'll say, okay, well, I know now I'm going to go put that DLL in, you know, maybe the applications directory itself. And then this way, when the next time the application looks for it, it finds my DLL first and executes my code rather than the intended code. This last story is about overly verbose error messages that eventually led to a full account takeover. So one thing that I often post as an informational or low vulnerability finding is verbose error messages that I see as an attacker. So if I'm testing your web application and I put something in and I cause the application to behave in a way that's going to generate an exception, there's a lot of times where I'll get a very verbose error message. You know, we expected a string piece of data at this line and this character, but instead we got an int, and you know, it caused this stack trace to dump out, and you know, it gives you a whole bunch of information. That's awesome if you're a developer, because it helps you identify what went wrong in your application. It's also really awesome as an attacker, because it helps me identify what went wrong in my payload and how I might be able to fix it. So in that simple case, I might think, okay, that was expecting int data and I passed it a string data. Okay, now I know I need to maybe reformat my payload to pass in some integer data instead. But again, there's a lot of times where developers or the clients that get those, they kind of write it off. They're like, well, we need those verbose error messages for our developers. I'm like, okay, have it in your dev environment, but don't have it in your production system. And like I said, there's some cases where year after year with testing, we find the same thing, and it's always a low severity, and they don't worry about it, and so we just continue to market and press on. Well, in this particular case, I was intrigued because this was testing something that I was new to from an attacker or a developer standpoint. It was using GraphQL as the API backend for this web application. And I had done some basic API stuff in the dark ages of web development, but I hadn't done anything with GraphQL. So it was all new to me, and I was like, as an attacker, looking at some of these verbose error messages, I was like, this is awesome because I'm learning how this app works and how GraphQL works as I'm attacking it. So let's set the scene here. The client web application is using GraphQL. They had suggestions enabled. Not a good thing. Again, maybe great if you're in a development environment, you've got new devs. It can help you work through any kind of issues that you may have, but don't have it on in production. I noticed there's a query that returns user object info, but based on my exploration of the rest of the API and the model there, I knew it wasn't returning all of the information. I noticed specifically there's one property that was not returned, and that was a system-generated password reset URL. So the system would generate it on its own, and then that became one of the user object properties, but for a good reason, they weren't returning that every time a user object was being moved or manipulated within the application. So I started fiddling around and put in some stuff that obviously didn't work. And this is an example of GraphQL with suggestions turned on that it might say. So I might have put in a query field for one, and it's like, well, we don't have one. Did you mean node? Oh, yeah, that's exactly what I meant, So then I reformat my attack to include the valid information, and then that might get me past one error, but then I get another error. And so I keep going through this iteration and getting my attack path just right till I finally get the data that I'm after. And I was like, okay, that's awesome. I can now return the data that I was after. And so this is an example, what you might see with a query, and it's getting like, ID, name of a user, and some other information. There might be some information that's not returned. So in the first one, it's not returning email, for example, but in the second one, they're asking for email, and so it actually comes back. So what I did was basically got to the point where I could go through and I modified the query on the fly so that I got back the password reset URL. And I thought, okay, that's awesome. I learned a lot of stuff in the process, but I was like, they may not be quite as thrilled about that because I was also logged in initially as one of their admin users for the application. And so they're gonna be like, an admin's supposed to get back that if they want to. And I'm like, well, again, I'd argue that maybe the admin doesn't need to get everybody's password reset URL because then you could have a rogue admin that starts going around and impersonating other users. So I kind of put that on the back burner and was looking at some other things. And that's when I had my, but wait, there's more. This particular application was doing a license check when you went to create new users. So the application, if I went to go add a new user to the application, for whatever reason they had their logic a little bit backwards, they would create the user, with all its properties and everything, and then they would check to see if there was an available license for the user. If there was an available license, it would put them in the right group and then send them on their way. They can log into the application, do all the things as a regular user, and life was good. If there wasn't a valid license for that user, it would error out, but the user was already created. And so I was like, what can I do with that user? Part of the response that I got back was the initial access information, and I found out I could log in as that ghost user, but I couldn't do anything. I didn't get any kind of UI in the application, and I just got a blank screen after I logged in. However, if I intercept requests and go through a proxy like Burp, I can still send GraphQL queries, I can add mutations, I could do all kinds of stuff through the proxy that way. So now I started thinking, okay, I've got a ghost user that can't do anything, but it's a regular user in the application. Can that user now return the password reset URL? And it turns out they could. So now all of a sudden my regular non-privileged user is able to make a query to get back information on any user in the system, including the admin users, and it includes that password reset URL. So then I tested that with the admin account that they had given me. It gives me back the URL. I go to that URL. It lets me set a password, and then I can log in as that user. So now I have privilege escalation from the regular user to an admin user through a feature that they didn't know that they had the capability. In fact, that was one of the things their GraphQL developer was like, I didn't know my application could do that. So ended up with full account takeover for any of the 68,000 accounts in the system. But again, chaining that to make it so that the client couldn't ignore it. In this particular case, I like that client. They've been really great to work with over the years. They always get a little bit nervous when we start a test because the first time I tested them, I think I had 5 or 6 criticals that included privilege escalation and a whole bunch of other stuff, and they were just like, all right, go easy on us the next time, but also don't, because they need that kind of stuff to be found so that it's not exploitable for real. And so that's that. I will open it up to Q&A. If you're interested in connecting on LinkedIn, the QR code there, I promise it only goes to LinkedIn. It's not going to rickroll you or give you something else. I thought about it real hard. I was like, I can make that maybe do something. And then I was like, no. Be nice. And then also my favorite high score screen, the ATM at BSides when I got in and took over the screen. One last thing I'll mention before questions. If anybody's brand new to InfoSec, there is a friend of mine out in the lobby. He's doing resume reviews. He's a career coach. I asked him to come here as a favor because in the talks that I've had with new people to the industry, they've mentioned how brutal the job market is out there right now. Looking for new jobs as a brand new person that's maybe doesn't have a whole bunch of experience, they're saying it's just brutal out there trying to get their resumes reviewed or seen. So there's a guy out there, David, he's doing resume reviews, he's a career coach. He's got some ideas that might be able to help you stand above the crowd a little bit and maybe get that first job. You had a question?
Yeah, I was just wondering about the GraphQL. Does that circumvent the MFA if the company's using MFA?
They were not using MFA, they now do.
That wouldn't get around, they still need that MFA.
So, yeah, if in the current, so I'm not able to retrieve the URL anymore, but if they would have had MFA, yeah, that would have stopped me from, I could have still reset the password, but I wouldn't be able to log in.
Yeah.
So, but they've since implemented MFA, so good on them. Any other questions? Yes?
On the DLL bit, DLL injection bit, I was wondering, whenever y'all do like DLL injection, do you make like a crafted DLL that tries to mimic the functionality of the original, or do you just toss a bad one in there and break the app? Or
for the quick and dirty, just toss a bad one in there. The first time I did that, the client did ask, well, like, you know, your DLL that you put in was just a quick and dirty, you know, so it's going to break that particular functionality in our app and our user's not going to use it anymore. And I said, yes, but I also had only 2 weeks on this engagement. If I was an actual attacker, and they're a big enough client that they might get this kind of attacker on their heels, I said I would actually build a DLL that would proxy the thing. So it would take the request, it would handle it, but it would also pass off to do my bidding as well. So that would take a little bit more time, obviously, but for this case, they were like, okay, we'll go with that. Other questions? Yes?
Can you go back over your method of injection, and then was this a fully
The what?
environment? The method of injection.
For the DLL injection? Basically just building so I know that application is looking for a specific DLL. Okay, we'll say app1.dll. Create app1.dll that has my code in it that's going to give me the reverse shell or the memory rifling. Put that in the folder where the application lives, and then when the application goes to make that call, it finds mine first, it loads the information I put in there, and it carries that out. Yes?
When you were reading the JWTs out of memory, how were you reading that out of memory?
I had regexes that would look for it in memory, and then
Did you create like a handle to that process? Or it was just
so yeah, I ended up using PowerShell for that. So PowerShell just, yeah, it connects to the memory for that process under the same context that the application is running. So in this case, the application was running just as a regular user, not an admin, but that's all it needed to be able to access the memory that application had access to. Yes?
Is your company hiring AppSec people?
We're not going to hire you, Michael. Yeah, I was going to say, he already works with me, so. Any other questions? Yes?
Real quick, can you explain how the client remediated the DLL injection vulnerability?
So what they started by doing is Microsoft recommends to have to do the search order in a different way, or to have it hard-coded to, like, you want to go to this specific DLL in this specific location, not just look for the first available. There's a whole TechNet article that goes into some different levels of protection against that. Other questions? Yes?
Stuff seems super interesting. I've never worked directly with it. If I wanted to start playing with it, kind of start at ground level and learning how to do application testing, what would you suggest? Like, where would I start? What would I look up?
Have you got a development background or no?
A little bit.
So
Minimal.
I always say it's a lot easier to teach a developer security than it is to teach a security person development concepts. So if you've got a little bit of a development background, I would look at maybe starting some web applications, you know, and there's purposely vulnerable ones out there. So like in the web application space, you've got Juice Shop. It's an OWASP project that's open and available for anybody. And it's made to clone like a modern e-commerce site. But there's tons of vulnerabilities in it. So you'll find cross-site scripting, SQL injection, command injection, all kinds of stuff. And there's a walkthrough guide, but there's also, you can just load it and then start going after it. So look at the different vulnerability classes. Most of them start with injection. So being able to put data in and have the application look at that. There's also purposely vulnerable desktop applications, APIs, almost anything you can think of. There's even purposely vulnerable IoT projects out there that you can load and then start to explore. If you're local to Charleston, certainly come out to the InfoSec meetups that we have the last Wednesdays of every month. There's people out there that'll be glad to talk to you as well. TJ's trying to tell me something.
They're gonna do like a ringside.
But yeah, there's plenty of resources out there that I would recommend, and then also looking at purposely vulnerable code. So when you find those applications that are doing, like for example, the juice shop, and you see an application error there for cross-site scripting or SQL injection, go look at the code and try to understand exactly what in that code, the way it was written, allowed you to have that vulnerability. Other questions? Yes?
You said there were InfoSec meetups?
Yeah, so Charleston InfoSec Group, established 2015. It's a local meetup of InfoSec professionals and people who are looking to get into the industry. We meet at Frothy Beard in West Ashley. Normally it's the last Wednesday of every month. For November and December, it's the second to last Wednesday of every of those 2 months because it's close to the holidays for the last Wednesday of the month. But yeah, so you can go to meetup.com and see more information. You can talk to me after the talk and get you plugged into the Discord. And so yeah. Yes?
The application you mentioned was just using a straight string check on the DLL, like app1.dll. It wasn't doing like a secondary hash check to make sure it was indeed.
It was not.
Would that be a good mitigation step?
It could certainly be, yeah. So it found this one. Does the hash of that match what I'm expecting? And if it doesn't, then throw an error. So yeah. Other questions? Yes.
Did the client have an EDR solution on the host that you were doing this on?
So this particular application is one that could be run by anybody on any Windows system. So they were more interested in the fact that, so their dev stations obviously have managed EDR, and many of their clients might, but not everybody's going to be running something. So they were concerned with the possibility that somebody would download their software, use it, maybe not have that, and then their software becomes the mechanism by which they get compromised. But yeah, certainly, if there was an EDR that had to be evaded, it's going to raise the bar. You're going to, it wouldn't be able to just use a, skeleton DLL with some basic information to do that. But again, that's going to be like a more realistic threat actor with unlimited time versus a 2-week pen test engagement. Other questions? All right, thank you so much.